Grade 10 superposition of pulses from the November 2017 examination. Two girls standing at opposite ends of a rope each make a pulse of the same speed. Pulse A with an amplitude of 4 centimeters moves to the right. So here's pulse A, and they are giving us the amplitude. And we know that the amplitude is the maximum displacement from rest position. So rest position would be where the rope is straight, the 0 position, and the amplitude is 4 centimeters. And we can see that it has its crest facing up that way. And pulse B with an amplitude of -6. So we can see that pulse B is a trough, the lowest point on a wave, and it has an amplitude of -6. And the negative tells us that it's a trough and it's in the opposite direction as pulse A. The pulses meet at point C. State the phenomenon observed when the two pulses meet. And we know that whenever two pulses meet at the same time and occupy the same space at the same time, this is known as the superposition of pulses. And we would state the principle of superposition of pulses from our exam guidelines, which states that the algebraic sum of the amplitudes of two pulses that occupy the same space at the same time. Name the type of interference that takes place when the two pulses meet. Now there are two types of interference. Constructive interference takes place when two pulses meet in phase. And that means when a crest meets a crest. So if I had two crests meeting, so here's a crest meeting a crest, then it would result in constructive interference, and that would result in a larger crest. So if this was 4 centimeters and this was a 4 centimeter crest, then it would result in a larger 8 centimeter crest, and that is known as constructive interference. And this could also happen if I had two troughs, then that would give me a larger trough. But in this case we have a crest meeting a trough. So we say that they meet out of phase, and whenever we have waves meeting out of phase, this is known as destructive interference. So to show what happens, they had asked us in 6.2 to draw a label diagram to show the resultant pulse. So what I'm going to show you first is before. So before we had pulse A, which is a 4 centimeter pulse. And we had pulse B, which is -6, and it is a crest. And pulse A was moving to the right and pulse B was moving to the left. And then we had when they meet. What would happen at point C when they meet? There would be interference taking place, and there would be some cancellation of the 4 centimeter crest with a 6 centimeter trough. We can see that we've got a larger trough. So the +4 at the top would cancel +4 at the bottom, and that would leave me with -2. So if I add them, the algebraic sum, +4 and -6, I would get -2. So this indicates to us that at that point, we would have a crest forming. And that crest would have an amplitude of -2 centimeters. And it is just for that moment, because afterwards, after point C where they meet, A continues. So A has now passed point C, and A now continues to the right, and B now continues with its original 6 centimeter trough. It would continue to the left. So this is very important to see the difference between the before, when they actually meet, you can call this during the meeting, and then after. And in this question, they only wanted us to tell them to draw a label diagram to show the resultant when they meet at C. So they were looking for this. Determine the resultant amplitude of the pulses at C. So we've done that. We said that the resultant amplitude was +4 and -6, which gives us -2, and that would be 2 centimeters, -2 centimeters. How will the amplitude of A be affected after passing C? Increase, decrease, or remain the same? So you can see from the diagram that we worked with now that afterwards A continues the way it was. So originally before A was trying to move to the right, and it was a 4 centimeter crest. During the meeting, superposition occurred, and after the meeting, A continues in its original direction with its original amplitude. So it remains the same. It continues in its original direction, so it continues to the right, and it maintains its original amplitude of 4. I hope you found this video helpful. Please like if you did, subscribe so that you don't miss future videos, and share these videos with your friends so that more learners can benefit from these lessons.